Hello, everyone, and welcome to Chapter 12 on solving environmental problems. Throughout this environmental science course, we have explored the dynamics of some of Earth's systems and between humanity and the environment. In this chapter, we will identify major issues related to environmental degradation. We'll take a holistic examination of major issues related to environmental degradation and problem solving. To do so, we will provide insights into how industries can function as ecosystems and how to assess the environmental impact of products and processes across their entire life cycle. Lastly, we will be made aware of the tools available for conducting life cycle analysis. We have covered a variety of environmental concerns that largely deal with biodiversity loss and ecosystem destruction, air and water pollution, climate change, endangerment and extinction of species, and finally, soil quality degradation. So, how can we effectively tackle these challenges? Addressing the multifaceted challenges of environmental degradation demands a comprehensive approach that is beyond limitations of a single course in environmental science. And instead of offering a definitive solution, this chapter will explore a range of strategies for tackling environmental issues and introduce frameworks for assessing the effectiveness of specific solutions. There are three general approaches that can be used for environmental solutions: governance, technology, and culture. Addressing environmental issues through governments means that it relies on the passage of laws and regulations, while technology approaches utilize the adoption of innovations in products, systems, or processes to solve environmental problems. Lastly, culture involves the social norms or practices. Some common tools used for governance based solutions include levying taxes, passing legislation for required standards in industry, as well as regulations on the production of pollution, and designating protection status to certain areas or species. The Wilderness Act was passed in 1964, and it created the National Wilderness Preservation System. This system initially comprised of 9 million acres of public and protected land called wilderness areas, and has since expanded to include over 100 million acres of land. These areas are chosen based on certain characteristics, such as that of being undeveloped and having uniqueness in their ecology or geology, or other features of scientific, educational, scenic, or historical value. Once an area has been designated as a wilderness area, they have protections and restrictions bestowed upon them, such as having no motorized travel. We can see in this interactive map of wilderness areas the city of Casa Grande in the center outlined with a red box. Just to the northwest, we would find the Central Arizona College, Maricopa campus. To the west, the map goes about as far as Yuma, and to the right, it saddles the Arizona New Mexico border. This region alone is home to roughly 36 protected wilderness areas and 2.8 million acres of preserved public lands. The preservation of public lands is not one within the scope of technological solutions, but of how we choose to govern and restrict the use of those lands. On the other hand, one technologically based solution that has a long history is that of artificial lighting technology. This chart graphs the number of hours of labor required to generate an hour of one lumen of light. A lumen is a unit of measurement of brightness equal to that of roughly a dozen candles. On the x-axis, we have the year, and on the y-axis, the number of lumen hours. At the start of 1800, 1 hour of labor generated roughly 186 hours of one lumen, or roughly 15 candles that would last 1 hour. The paper this graph was derived from tracks the development of candle technology to kerosene lamps in the 1860s, the first electrical service and lamps in the late 1800s, and finally the compact fluorescent light bulb in the late 1980s to 1992. The paper was published in 1998. The final year measured was in 1992. However, at this time, light-emitting diodes, or LEDs, had not yet been incorporated to this graph. And as we can see in this chart here, LEDs are almost twice as efficient as compact fluorescent bulbs, or CFLs. In addition, they last longer and are cheaper to manufacture. This has important implications to our energy footprint, since not only are the input for energy for the production of these sources of light down dramatically, so is the energy to operate them. Consequently, the US Department of Energy estimates that lighting only makes up about 5% of the average US household's electricity consumption today. Culture plays a critical role in environmental solutions. An example of this involves countries where cycling to work or using reusable grocery bags is a social norm. Addressing cultural change is a complex matter, and this chapter primarily centers on governance and technology as key aspects of environmental solutions. Solutions in the environmental realm typically involve an intersection of cultural, political, or governance, and technological dimensions. Electric vehicles are an excellent case in point, beginning with the technological solution that emerges through the development of more efficient electric vehicles. Illustrating a governance solution, the US federal government provided tax incentives for consumers purchasing electric vehicles. And then widespread use of electric vehicles reflects cultural acceptance, highlighting the cultural dimension of the solution. This concludes our discussion on approaches to environmental issues. In the next section, we will briefly discuss how environmental politics and activism play a role in environmental issues.